I'm Marshall Kozlov, and this is Arsenal of Democracy.
Never before has our American civilization been in such danger as now. Danger against which we must prepare. But we well know that we cannot escape danger by crawling into bed and pulling the covers over our heads. We must be the great arsenal of democracy.
Two of the biggest technological developments in this space are the mass adoption of SpaceX's Starlink technology, which has enabled the transmission of internet to previously untouched regions of the globe, and of course, all of the recent advances in artificial intelligence that have manifested themselves on the battlefield. Combining these two developments together requires connectivity. My guest today, Dan Wright, co-founder and CEO of Armada, is working to do just that, taking these developments and expanding them to the true edge cases where future conflicts and civilian use cases will play out.
AI is, by its very nature, it's real time. It's providing, decision intelligence that can be used in real time in important tactical decision making, right? It's also automating certain tasks that humans would do. And if you think about why is that important? It's because split seconds matter in that type of environment. And also, wars are not being fought the way that they were fought 50 or 100 years ago with, just manpower.
20 years ago.
20 years ago, right? It's being fought with technology. It's being fought with autonomous vehicles, drones, counter-drone technologies. And now, we need to bring the latest AI to bear.
Hope you all enjoy the conversation. Dan Wright, welcome to Arsenal of Democracy.
Thank you very much for having me.
Before we get into Armada, I'd love to talk about why you're here in DC this week. We're both going to be attending the Hill in the Valley Forum. It's basically a big confab that is broadly focused on technology and national security, but today's iteration that folks are seeing is going to focus on the intersection of AI and national security specifically.
Right.
I'd love for you to set the table and talk about your interest in the topic, but also how you're thinking about the space this week.
Yeah, I'm excited to be here this week. And this is the third year I've been at the Hill in the Valley. Great to see it continue to grow. And I think it's a perfect topic. Right now, I think we're sort of in a existential moment without elaborating, too much. I think that right now we have to figure out how are we going to win on AI. There's no option to get second place. And China and all of our adversaries are not worried about regulation. They're not worried about playing by the rules. They just want to win. So we have to figure out how we're going to beat them. And, the good thing is this Hill in the Valley's got all the brightest minds in government, brightest minds in tech coming together to try to come up with some solutions.
And it's interesting because even you just opening with, we need to win. If you think of like the first version of Hill in the Valley that I was at, so much of the DC debate was, well, is there a competition? Do we need to quote unquote win? That consensus is fully formed now. So now it's actually getting into the how.
That's right.
Rather than the why. So I think that's a particularly exciting moment. I'd love for you to kind of articulate then, if you've been doing these for roughly 3 years, how has the DC space adjusted to this topic area as you've encountered these trips in the various meetings you've been on?
I would say just the sense of urgency and the willingness to engage with founders, technology companies to try to solve big, meaningful problems has increased a lot over the last few years. And specifically with AI, there seems to be this acknowledgement that we can't wait to sort of come up with a strategy that's a winning strategy. We need to do that right now because the rate at which AI is progressing is extremely fast and picking up steam. And also, again, our adversaries are very focused on it and have, very organized efforts to try to win. So we have to, organize ourselves and make sure that we come out ahead.
We're going to skip ahead a little bit in the script here. You write and think a lot about decentralization as relates to Armada. And as I'm thinking about the Arsenal of Democracy framework, it's this idea that in the United States, we don't just have the DoD, the Pentagon, and the White House and Congress, we actually have founders and VC firms. We have all these different forces who are working on these problems in ways that sometimes sync together, sometimes don't sync together. How do you understand how decentralized we are as an ecosystem when it comes to solving big problems? Because there's no declaration from the White House, we're going to solve AI. So I'd just be curious how you encounter all these different parts of the ecosystem, sometimes meshing, sometimes not meshing well together.
Yeah, I mean, I think it's interesting because you have a lot of companies going into defense tech now, which is really good. I think venture money is flowing there in a really good way. And so traditionally, you've always had like the valley of death. And I think that the reason why so many companies have tried and failed in the defense space is that it is decentralized in the way that you're talking about. You can't just convince one person or even a handful of people that something is the right approach to solve a big problem. You have to convince a lot of people, right, across different branches of government. And now I think that there still is that valley of death, but it's getting a little bit narrower. It's getting a little bit more possible to get through it. And I think actually one of the really encouraging things that I'm seeing is that there's some ability to pattern match, right? If you think back like 20 years ago, before SpaceX, before Palantir, before Anduril, people just, figured that there was no way for new innovative technology companies to come and be successful on Capitol Hill. And now that has changed. Now you can actually look at, okay, what have those companies done and done well? And how can we take pieces of that to, find success?
And that's a great pivot to Armada, like the specific company, the idea, and then we'll get in kind of the different ways that you're attempting to cross that valley of death.
Yeah, great. Yeah, so Armada is sort of like AI in a box. We are bringing full stack compute infrastructure to very remote, hostile locations wherever it's needed. And we're doing it together with the latest AI models to process and make use of large amounts of data at the edge on the ground where it's most needed. And the way I like to describe it to people is it's sort of like the magic of ChatGPT, except for instead of automating back office tasks, automating customer support, automating your ability to write a nice poem for your wife, we're actually focused on taking that same type of magic, but applying it to operations and to really meaningful problems that can, spell the difference between winning and losing, life and death. And that's our focus.
I think going back to the crossing the valley of death point, a way that you can address that is you can have dual use technology. You could have civilian applications, you could have national security applications. Even in your definition of your mission, you're talking about remote and hostile. In some ways, there are plenty of remote use cases that are very civilian focused. There are other hostile cases that are obviously very national security focused. I'd love for you to sort of explain how you define remote and hostile through the lens of there being civilian and military applications of what we're working with here.
Yeah, I think the remote piece is really important. Edge computing, which is, we're an edge computing company. That term has been around for a really long time. What people meant when they said it, though, was it was the edge of the cloud provider's network, the edge of 5G networks. What happened was Starlink came along and sort of changed the game, bringing connectivity to all of these really remote edge environments beyond the cloud provider's network, beyond those 5G networks. And that's important because that's where a lot of the data is, and that's where a lot of the conflicts are. If you think about what's happening in the Pacific theater, if you think about what is happening in Ukraine, if you think about what's happening in the Middle East, and where combat is going, which is it's increasingly global. We also have to think about space now in a way that we didn't think about before. You need to have the ability to make cutting edge technology available wherever it's needed and whenever it's needed extremely rapidly. And so that's what I mean. I mean, really those remote edge environments where these conflicts are, that's our focus.
And I want to make this very tangible for listeners and viewers. When you're pointing out that this data is there, but it isn't accessible, what does that mean like in an AI context?
I mean, if you think about like, what is AI, right? AI is, by its very nature, it's real time. It's providing, decision intelligence that can be used in real time in important tactical decision making, right? It's also automating certain tasks that humans would do. And if you think about why is that important? It's because split seconds matter in that type of environment. And also, increasingly, wars are not being fought the way that they were fought 50 or 100 years ago with, just manpower.
20 years ago.
20 years ago, right? It's being fought with technology. It's being fought with autonomous vehicles, drones, counter-drone technologies. And now, we need to bring the latest AI to bear. All of those things that I just mentioned, they create a lot of data, right? They create a massive amount of data in these locations, whether you're talking about a drone, you're talking about an autonomous vehicle. And we bring the ability to process the data from all of those things as part of highly resilient infrastructure to enable better decision-making, better tactical response.
So that's fascinating. So when you're talking about infrastructure, does that mean infrastructure in the remote or hostile space itself, or like how does this ecosystem work broadly?
Yeah, well, so if you think about like prior to Armada, how did this all work, right? Prior to Armada, a lot of data was generated, and in some cases there's some compute capacity, like on a drone or on a counter drone technology, et cetera. But a lot of times there was not enough compute in these locations, and so a lot of the data, just nothing was done with it, honestly. And then sometimes what was done is it was sent in batch to some remote location. Some analytics would be done, and then they would try to use it to inform future decision making. But that didn't help with the current situation, right? And so what we're doing is we're allowing you to use all of your data, process it in real time at the edge, and then just send the pieces that you choose back using Starlink or some other satellite backhaul. And that is new. And I think that is really important because number one, again, it's real time versus high latency. It enables better decision making, better response. It's also much more cost effective because it turns out sending a lot of data to some remote location can be very expensive, and also involve a lot of manpower to sift through it to figure out what pieces matter and what pieces don't. And then it's also more secure because the number one time where you have a sort of a issue with a hack or sort of data security is when data's in motion.
I think we should note that when you're making reference to SpaceX and Starlink, you're not just doing that because they're cool. You're obviously working with these pilot programs like with Starlink itself. So I'd love you to kind of, and once again, like this stuff is like new, it's like kind of private, so you don't have to go like too in detail, but just sort of like articulate like what that kind of looks like from a thought process perspective.
Yeah, I mean, it's not just pilot programs. We have customers, and a lot of them are using Starlink. They might also be using other types of satellite connectivity, and then some of them use private 5G. Some of them use other types of connectivity. But Starlink really is a game changer for some of these more remote locations. And what customers are looking to do is to make full use of that. And then what can they do on top of that? So to make full use of that, we enable things like fleet management, bonding of multiple Starlink terminals together so you can get a bigger pipe for more data. But then also they'll say, okay, well, once I'm doing that, what about my drones, right? I'm using drones for an emergency response scenario, let's say in a state, right? And I want to be able to respond to a hurricane or an avalanche or some bad thing that's happening, or even law enforcement in remote areas. And now you have, amazing drone technologies. Like we have a partnership with Skydio as an example, and a lot of states are looking to use those technologies in combination with Starlink, and then connect our SaaS product kind of brings that all together. And then what they're saying is, okay, well, now that I have all this in place, rather than sending, again, data from, let's just say, drones to some faraway location for processing and then to use for better decision making, I can actually just do it locally on site. Right. And it's use cases like, okay, help me using computer vision on all that data from drones, identify, where should I focus? Where is there a potential issue, whether it's a security issue or somebody who's in trouble that needs help, and then respond faster and better.
I'm really interested, and this was covered in some of the reporting about Armada. Why does this opportunity exist in the first place? In the sense that it seems like there's a world where Starlink could have prioritized this feature in the first place. Like, why is there this opportunity to build on top of Starlink's hardware?
Yeah. I mean, Starlink
And they're busy. There's a lot going on.
Well, I was going to say, they are a machine. Like their engineering capability is incredible, obviously. But they are focused on, sending rockets up to space, and they are focused on making life, multiplanetary. And obviously Starlink is a piece of helping to kind of fuel the engine that makes all of that possible, right? We have found them to be very open to complementary technologies that allow for, we call them killer applications of Starlink, but with additional technology that is additive to what they're already doing and also what they plan to build. And so that's really what we've tried to focus on is at every step of the way, making sure that we are unlocking these killer high value use cases for customers. And that involves, Starlink obviously for the connectivity piece, but then you have to really think through the rest of the compute stack, and that's where we come in.
Yeah, I think what's fascinating here is that it'd be easy to hear what you said and kind of misinterpret and think like, okay, so Starlink is the equivalent of the iPhone, and you're like building all these apps and software for it, but you're doing that, but you're also building like hardware of your own. Like what is that kind of like intersection? Because that seems what's pretty new here.
Yeah.
Hard tech is hard, obviously. Talk about that.
Yeah. So the way I look at it actually is Starlink is the connectivity, right? Starlink is the network, which is an incredible, foundational piece. If you don't have the internet, you don't have much, right, to build on. And so they're making that happen. What we're building is sort of almost like the iPhone, but for applications at the edge. And let me tell you what I mean by that. So we have infrastructure, right? And we have these modular data centers, which are called galleons. And if you log into our software operating system, which we call Commander, again, sticking with the Armada theme, you'll see all of your galleons, these modular data centers all over the world. And then there's a marketplace of different AI applications that can be deployed with one click to the edge, to one or as many of those galleons as you want. In that same fleet map, you also see all of your Starlink terminals. You can see drones, you can see other IoT devices and manage it all there centrally. And so the beauty of that is that we don't have to develop all the applications, right? We've opened up this ecosystem where we're already partnering with a number of different companies, really innovative companies. Obviously, I mentioned Skydio, but companies like Metaspectral, which is taking hyperspectral data and helping to speed up the mining exploration process is one example, right? We don't have to build that because it's already been built. And because we've opened up this ecosystem, customers get to take advantage of really interesting sort of cutting edge AI applications in all these different industries. And it makes us so that we can scale, right? If we tried to build all of those apps ourselves, it's going to be impossible to scale.
So with the reference to Galleon and Commander, I will ask like Armada origin, significance of the name. Sometimes names are kind of random, but once you've built 3 different brands within that name, I think we could say there's a theme.
There's a definite theme. Yeah. So the Armada name started off in reference to the galleons, these modular data centers. A galleon obviously is a large ship, and we felt like that was a very fitting name because these things travel and sometimes will travel in groups wherever they are needed to solve a problem, right? And I also just really wanted to kind of build this idea that AI is not something just for the back office. It's wherever you need it to be applied on the ground to solve the most meaningful problems. And then we've kind of continued to build on that. Commander makes sense because, again, you're sort of commanding what is happening on all of the different galleons and then your IoT devices. And we'll probably continue to riff on that.
I will say, if I worked for y'all, I would have forced Commodore instead of Commander. My little editorial.
We'll take that one under advisement. That's a good idea.
There's only so many C's you could really use there. So I want to kind of take a step back because obviously this is like a policy and history show. You read about in the announcement of the company like 3 different trends that are driving this. So deglobalization, the lack of remote infrastructure, then obviously the decentralizing nature of the 4th Industrial Revolution. I'd love to just go through each of those because I think the way to tie this conversation back together is we have these big 3 trends. And Armada is taking those trends to their logical conclusions in this case. So let's start with deglobalization. Like, why does that matter to this?
Yeah, I mean, deglobalization matters because as a result of deglobalization, people are much more concerned around data residency, right? They want to make sure that they know where their data goes. They also want to make sure that they know what's happening with their models, because the models are really your competitive advantage, in kind of the AI age. And if you don't sort of have those proprietary to yourself, then you lose your advantage, right? And so we are very focused on providing resilient infrastructure that can also be resident to the data, right? Rather than requiring the data to move, which also opens you up to, again, cybersecurity attacks, different issues. And so that is really how we look at it. Deglobalization, I will say, it's gone extremely fast. And it's interesting. Now we used to, talk to people in different countries, and we'd say, hey, you need the data to stay resident within, the country's borders. And oftentimes now they say, oh no, I can't actually leave this city, or I can't leave this site. And so not only is it deglobalization from sort of a macro geopolitical standpoint when you're talking about different countries, but it's also down to even, smaller geographic areas at this point.
So it's just like a contested threat environment where it's like in that case then.
Yeah, I think there's just a heightened awareness around the importance of preserving your data and preserving your models and keeping that as your advantage.
So for the next one then, we kind of got at this, but it's good to be exact. Just like the remote infrastructure itself is lacking. So you just said in a previous answer that this is about being able to get this edge infrastructure out there. What does the status quo look like? Like, let's say beyond just the fact that you're getting limited amounts of data. Obviously, there are existing tools. Like, how lacking are those existing tools?
Yeah. So today, things have changed now with Armada. But if you think about like before Armada, you had the public cloud, right? So you had Microsoft, Amazon, GCP, and obviously the cloud has been phenomenal. It has really opened up access to cloud computing for the masses, right? And that has worked extremely well for the past 20 years. But what has happened is that all of the data, or a lot of the data, is going to the edge. Gartner has a stat that says by 2025, 75% of all data is going to be generated at the edge. And it makes sense because the cost of cameras and sensors and drones has gone down 10x in the last 5 years. And people are using more of those things. They're using them on oil rigs. They're using them in mines. They're using them on battlefields. They're using them in factories. They're using them on trains. You go on and on and on ships in the middle of the ocean, right? And increasingly people are realizing that while cloud is good, processing data locally in addition to that in these remote edge scenarios is very helpful, because it allows you to, again, get to real time because you're not having to send data thousands of miles away, but also do it in a way that's secure and more cost effective than trying to do everything in the cloud. And the nice thing is you can get the benefit of the latest open source models. You can train models in the cloud, but then you can run them at the edge and do it in a way that's much more efficient.
Last but not least, just the decentralizing nature of the fourth industrial revolution.
Yeah, I mean, I think what's really interesting, again, kind of like edge computing, IoT has been talked about for 15 years now, but now it's happening. Now it's happening in an entirely different way. And again, it's because these things have become much more cost effective. And so they're becoming much more widespread. You've got more companies, working on that stuff. And I think you're only going to see that continue, which is why you see, like, if you look at a chart of the amount of data that's being generated from IoT devices, it's increasing at an exponential rate, and it's, picking up steam. And that's not going to slow down. We're going to have more connected devices. Pretty soon, everything that we use is going to be connected to the internet. And all those things are creating just massive amounts, petabytes of data that need to be processed. And again, trying to do that all in the cloud, especially when you're in some faraway location, isn't the best answer.
What's the 10-year vision here?
I mean, I talk a lot about we're now in a distributed world versus a centralized world. And some of what you just described with the fourth industrial revolution is really feeding this, right? All of the sort of companies that are forming the backbone of our, society, from the energy companies to, manufacturing, et cetera, logistics, they are all now using IoT at massive scale. And that is going to continue. Same thing in the public sector, not just with the DoD, although obviously that is happening. That's how wars are going to be fought. But also, even in the state and local context with, disaster response. And so to me, it's like the future is distributed. The data is going to be generated in all these locations all over the world, all parts of land, wherever you are, all over all the oceans, and then also in space, which is another interesting topic. I was just at Space Symposium, a lot of talk about, compute in space, like that is coming.
Yeah.
And so the vision is that 10 years from now, you have a distributed world with a lot of distributed data, and you have distributed infrastructure to process it all. And that's where we fit in.
Which is why, the company itself is described as a space company, as like space, as in like spatial, as opposed to purely just being a pure AI play. So, last question here, y'all are moving fast, really fast. What is the foreseeable next challenge beyond just implementation?
Yeah, we like to say, first of all, that we are a space company, but with a terrestrial twist because, again, these galleons, a lot of them, and Starlink, there's obviously the space component, but they're all over the land and in the oceans, and there's a lot of data in all those places as well. So it's more about distributed compute, but space is obviously a big part of it. In terms of your question, the big sort of next step for us is just working hands-on with customers and our partners to solve big problems. And that is really our focus across all these different industries, are high-value use cases that are not just a tiny step forward from the way things are currently done, but a massive step forward. I tell our team, it needs to be so obvious that this is better than the status quo in every one of these industries, in the work that we do in the public sector, that you have to do it, right? You have to do it. It almost becomes, required. And so that is really what we're focused on. And you'll see that coming from Armada a lot in the coming, quarters and years, us telling these, stories of these companies that are transforming and embedding AI in their operations versus just the back office or just, using it for customer support to solve, meaningful problems. And, just to give you one example, you think about mining, right? A lot of people don't know much about mining outside of mining, but it's, foundational to our entire economy. That's where we, get all of our minerals. The interesting thing that you learn as you dig into that is that the way that the exploration process is done has not changed in a very long time, right? It's teams of people going around, and they have to manually survey large geographic areas to figure out the best place to mine. Well, now you can use, AI and you can use hyperspectral data to figure out the best place to mine much faster, in months rather than years. And that's going to continue to speed up. And you think about the impact of that.
Yeah.
Huge, right? Just in terms of production, in terms of, for these companies, their ability to win more projects, do more projects, and just increase market share. And the same thing is true in oil and gas. And, you go down the list in every area, for industrials, you're going to see entire industries change. And our job is to make that change happen faster. And that's where, again, telling the story of these companies that are making that transformation, and sort of we talk about these AI heroes, the people on the ground that are using AI to do their jobs better. That's what we're going to focus on.
Well said. Dan, thank you for joining us on Arsenal of Democracy.
Thanks so much for having me.
Thanks for watching. Don't forget to hit subscribe below so you don't miss any episodes of Arsenal of Democracy. If you'd like to learn more about the topics covered on this episode, or just are interested in broader content on U.S. foreign and domestic policy, be sure to go to hudson.org. See you soon.